Good morning or good afternoon, depending on where you are. We are continuing with our lecture series in thermodynamics. My name is Professor Duke Orata. Today we want to look at the real powerhouses in industrial systems. That is the boiler, the so-called boiler or the steam generator. The boiler is a fundamental power source for most of the industrial complexes and also is used in production of electric power and so forth. And so it's a fundamental aspect, fundamental infrastructural aspect, which is useful in industries, very useful in industries. And these boilers are basically, they are basically closed, they have a constant volume. They have a constant volume. And when combustion of fuel, that is fuels are burnt, heat is produced. That heat energy, through because there's thermal contact between the boiler and the furnace, there's thermal contact. What does that mean? It means that heat can be transferred between the two systems. So if you think of the boiler as your system and you think of the furnace as being in the surroundings, remember our introductory lectures in thermodynamics, we say that in that particular case where we have heat being transferred between the system and the surroundings, that kind of a system is not adiabatic. Adiabatic systems are those ones where no heat is transferred into the system or out of the system. So if you look at your boiler as a system, that's the boiler as a system, and you talk of the furnace, the surroundings, so you have your surroundings, and you have the boiler as your system. What we are saying is that there is thermal transfer between the boiler and the system, which is now the furnace and the boiler. So there's thermal transfer, that is, heat can be transferred. So this heat can be transferred between the system and the surroundings. And remember, we talked of systems. We said there's one which was called isolated system, which is a closed system. It's not in thermomechanical contact. So in other words, heat cannot be transferred between the system and the surroundings, and no work can be done across the walls. That is not the case with the boiler. And so when you burn this fuel, when there's complete combustion, what is combustion? Combustion is the total oxidation of a substance. So that, for example, if you burn a hydrocarbon, then when you burn it in oxygen, you will produce, if it is totally oxidized, you produce carbon dioxide and water. And so a lot of these combustion processes produce heat, a lot of heat. And of course, when that heat is transferred to the boiler, then in the boiler there, the water in the boiler can be heated into steam. And of course, the quality of the steam depends on the temperature of the boiler and the pressure of the boiler. The higher the pressure of the boiler, the more efficient it is. Unlike in the case of the condenser, remember the Rankine cycle? Where we had the boiler, let's look at schematic, and then we have the pump, and then we have our condenser, and then we had our turbine. Remember that? The higher the pressure, high pressure, more efficient. Low pressure, the condenser is more efficient. So these are fundamental knowledge which you must have as you're dealing with this kind of system. So the water will be heated to various types of vapor, level of vapor, in terms of quality of the vapor, which is given by the dryness fraction. Remember the dryness fraction, which is mass of dry steam divided by mass of dry steam plus mass of liquid. So that dryness fraction, the quality, will depend on the conditions, the thermodynamic conditions in that particular boiler. Now, let us move to boiler now. The boilers are not all the same. They have a classification. They have a classification, and for you to classify the boilers, you must know what are these particular indicators or parameters you are looking for. Let us list them down. One, for classification of boiler, we need to know a few things. What is the content in the tube? The content in the tube. Two. Now, when you know the content in the tube, how many tubes are there? The number of tubes. Now, we want to know in terms of circulation of water and steam. Water and steam circulation. The other thing we need to know about this particular boiler is one of the things which we need to know about the boiler, other than the content, number of tube, number of, we need to know the axis of the shell. And we need to know the position of the furnace. Furnace is the cooking system, the heating system, where heat is generated on combustion of those fuels. Depending on what type of fuel you're using, it's combustion, heat is released because there's thermal contact between the boiler and the furnace. Heat is transferred into the boiler, and of course the water is heated to various degrees of quality in terms of steam, and then the axis and then position of the furnace. Finally, you need to know the purpose. Why are you having that boiler? Because why you're having it will influence a lot of things. So these are fundamental. We need to know the content in the tube, number one. We need to know the number of tubes. We need to know water and steam circulation in that system. We need to know the axis of the shell. We need to know position of the furnace, and we need to know the purpose of the boiler. What are you using for? Because that makes a lot of difference. That makes a lot of difference. So, let us keep our classification indicators by our side so that you don't lose them, so that you're able to see them in your mind. So let's keep those classification indicators there. Let's leave them intact. So, we have talked of content in the tube. There are two types. There is fire tube boiler and there's water tube boiler. So there's the fire tube boiler. And the best way to do it is to illustrate schematically what happens. In other words, we have the hot gas, fire and the hot gas moving within the tubes, and of course when they're in contact with water, there's thermal transfer of heat, and so they get heated up depending on whatever level you want it to be heated on up to. So, fire tube boiler. Fire tube boiler. Let us just have a schematic of it. See how it looks like? That goes to stack. Basically, the exhaust through which those flue gases are emitted. those gases are emitted. So of course we have our pipes. Try to do it as best as we can. We have those tubes. Let's try to do it as best as we can. And of course, the water system, which is in contact with these tubes. Steam out. And you have a furnace. So we have combustion of those fuels, and of course heat and hot air are released. You have water. So we have our water. Try to get this as best as we can. So this is heat. Or let's call it. So we have fire, hot gas. So we have our water here. So the content in that tube, in those tubes, is fire or hot gas. And so because we have this system where we have water in contact with those tubes, then heat is transferred across the two walls, because there is thermal contact between those two. This is a fire tube boiler, and the stack, that's where we have those exhaust gases leaving the system. They're normally called flue gases. You can have the nitrous oxide, the sulfur dioxides, and so forth, and so forth. That's very, very important for us to note. Now, that is a fire tube boiler. So we have the furnace, hot gas or fire, we have steam out, and of course we have the exhaust system where those gases, those flue gases exit the system. That is a fire tube boiler. Then we have the one where the content in the tubes is water. So that's a water tube boiler. That's a water tube boiler. Let's look at the water tube boiler. Water tube boiler. I repeat, water is in the tube. Now it is not fire or hot gas, it is water running in the tubes. So again, we can have our schematic of it. Let's do a schematic of it as best as we can. Now we have water in our tubes. We have water in our tubes. This is water in. water in, and we are not very accurate in our drawing. Steam out. So water, and of course, another tube there. Then also blank. So of course we have the hot gases moving in between. So stuck. But now this is water. Now that is fundamental furnace here. So we have those two types, fire tube boiler and water tube boiler. The difference, the content of the tube. One is the fire and the hot gases in the tube hitting the water in the vicinity, in contact with it, in thermal contact with it. The other way, it is now water in the tubes, and of course we have the heat being produced, being in contact with those particular tubes, and we are able to generate steam to whatever level we wanted. Now, it is very, very important to note that even as we are talking of water, it is very, very important to note. Just notice that we have steam out, water in, furnace, then we have the tubes and water in the tubes, and so forth and so forth. Now, there are very important things which we need to know, which can have serious implications on the performance of this boiler of yours before we move to the other classification criteria in terms of the water which you feed into that boiler. Water fed into the boiler. Very important. The water you feed into the boiler makes a lot of difference, because if that water has a lot of dissolved solids, then that one is not good for you, because there will be scaling on the walls. What is scaling? There will be depositions on the wall, and what can that do? That can make the system become adiabatic, in quotes. In other words, an insulator, so that heat is not transferred across the walls. So you need to worry about the level of purity of your water. This is total dissolved solids. And if you don't do that, you can be dealing with very serious cases of scaling and have to make your system insulating or adiabatic, in quotes. No heat transfer across the wall. So it's very important that as you're using this this steam generator, it's probably good to use have a treatment plant, a water treatment plant, which will ensure that these kind of things. And that's why you have the so-called blowdown, so that water is released, and that helps to remove some of these tedious particulates. Very, very important for us to note. And then the conductivity of that water is very important. Normally should be below 5 microsiemens per meter. Remember conductivity, just to remind you, remember resistance of a system is related to the length, is and inversely proportional to the area. And so when you have R, that is K L over A, because they are proportional in that manner, that is the specific resistance. That is the specific resistance. And let's call it pi. And that 1 over pi is the conductivity. So these quantities are very, very important. Very important, so that you look at the quality of the water which you are feeding into your steam generator or boiler unit. That's I just needed to mention that in passing. Now, the other thing which we said is the number of tubes. That is very straightforward, just like it says, the number of tubes is how many tubes and the system. So you can have a single tube boiler. Where you have only one tube. Where you have only one tube. In fact, it's more like a vertical boiler. More like a vertical boiler. Because you have your opening there. This is a vertical boiler. So boiler is just a single tube. Just a single tube. And so when I talk of the vertical boiler, that's important in terms of we have as well covered the axis of the shell. In other words, it is vertical. So we can cover both with that. So we're talking about a single tube boiler. Just use the fact that you can use a vertical boiler, which could be a single tube boiler, and of course that is the axis of the shell is vertical. And of course there could be one where the axis of the shell is horizontal. So I can kill two birds with one stone. As I'm talking about a single tube boiler, this is a vertical boiler. I can also introduce that's the axis of the shell. In this case, it's vertical. The other one is horizontal. It's horizontal. Inclined is rarely. But what is horizontal? Horizontal, if you look at steam locomotive, for example, you can think of that as a horizontal boiler, a boiler whose axis of the shell is horizontal. This is common of locomotive boilers. Those old trains which we had, which were burning steams, the very first generation of trains which are burning steams, and think of that as a horizontal orientation in terms of the axis of the shell. And so that to talk of vertical, horizontal axis. So we have taken care of axis of the shell in addition to talk about number of tubes. You could have a single tube boiler or you could have a multi-tube boiler. Multi means many. Seems mean many tubes. Many tubes, like we saw that in fire tube boiler or water tube boiler. Those many tubes. So that is straightforward and you don't have to worry about that. So we have taken care of content, the tube, number of tubes, axis of the shell, and you have seen that. Now, position of the furnace is very, very important also in the classification of boilers. Is it internal or is it external? So in certain cases, the furnace is in the boiler system. It's internal. Position, very important for us to know. Those are very important things for classification of boilers. Talking of position, is it position of furnace? Can be internal, that is in the boiler, or external, that's outside the boiler. Normally, it is preferred for efficiency in terms of generation of whatever quality of steam which you have and efficient thermal contact between your system and the surroundings. Remember, your system, you said, is the boiler and the surroundings is the furnace and wherever it is. So for efficiency in thermal transfer, internal boilers are more the furnace, internal location, the furnace is better than externally located furnace. And this is much more efficient in terms of effective thermal transfer. Very important for us to note that. And so the other one which we now need to know is basically what is the purpose of this boiler. The purpose of the boiler, no, let's not come to the purpose first. Let's look at water and circulation. We are skipping that. Water and steam circulation. What do we mean by that? Water and steam circulation. Remember, we have said you are feeding water into the boiler. Then heat is exchanged, thermal transfer. The steam is heated to whatever quality, the water is heated to whatever quality of steam or vapor you want it to be heated. Depending on you can adjust your systems. You can adjust your system. Now, in other words, water and steam circulation is very, very important. There is a boiler where the water is natural boilers. And where we have water-fed boilers. Now, there's a very thin boundary between those definitions. When we talk of natural, we are thinking that this water is not assisted. It's the process of water moving to the system is not assisted. It flows into the system, using just the mechanism, the hydrodynamics of that system, without any major system. But there is where water is fed into the boiler. Where water is fed into the boiler, here you will need a pump. You might need a centrifugal pump. You might need a centrifugal pump. That's like you saw in the ranking circle, we have a pump. We have a pump. And of course, work has to be inputted into that pump. And of course, remember, when we did the efficiency of the which is output over input, we have to take into account that work inputted into the pump and the work output at the turbine. So very, very important for us to remember that. Now let us look at that. Let us look at what does that mean for us. Let's look at what that has mean for us. Now we don't need much of this because I think by now you know them. We are only left with purpose of the boiler. Now you will use a centrifugal pump to effectively assist in pumping the water into the boiler. And centrifugal pump is just for your information so that you are not completely lost. So we have our system here. Let's say that's the centrifugal pump. We have a system of impellers. These are called impellers. And so you have your suction side and you have your pressure side. And this thing is rotating. It's rotating. So that rotational kinetic energy throws that water into the volutes here, what is called a volute. And of course, it finally exits. So the impeller is think of it as a blade which hits the water, makes it flow faster. That's called an impeller. It's in centrifugal pumps. We are going to talk about those at some point when we do those lectures in chemical engineering. Then you're going to see the significance of some of these pumps, or when we reach them in this particular case. But impellers are very important. They're like blades which hit the water, and it's rotating. So the rotational kinetic energy assists the water to move. Now think of it this way: we have the rotational kinetic energy in the pump here being used to pump out there. But remember, in the turbine is the other way around. It's the reverse. It's the other way around. Energy now being produced as a result of the rotation of the turbine. So they are almost like this one is in that direction. For the turbine process is in the reverse direction. Now we want to talk about purpose of the boiler. Purpose of the boiler is important in the sense that it will tell you, for example, it will tell you what kind of boiler you want to deal with. Do you want to deal with a stationary boiler? What's a stationary boiler? A stationary boiler is like those used in power plants, in electric power plants and so forth, because you're not moving the boiler back and forth. So you build for its a support system. Of course, the masonry is very, very important in terms of construction of the support foundation for that boiler. Now, it is stationary. It is there doing its work, generating steam, driving turbines, and so forth and so forth. That's a stationary boiler. So it's basically the boiler on a fixed sound structure. So the masonry is critical in that particular case. So if you just use one, remember the boiler and the kind of activities you got there, even the temperatures. So you wouldn't put a plastic. We use melting point very low as a support. So you'll probably use refractory materials, which you must select the best one. Then you have the mobile boiler. And the mobile boiler Basically, a good example is the locomotive boiler. I like this because everybody has seen it. Locomotive boiler. And of course, you know that if you look at those old locomotives, it's moving. That's the steam engine is in front, is moving. It's moving from one town to another city, so forth. Those are mobile boilers. So you need to know stationary and locomotive boiler. There are many types of boilers. There's the Lancashire boiler. There are many types of boilers which we don't want to spend our time on. What we need to do is, what we need to worry about is the fundamental principles behind the boilers, whether it's Yarrow boiler, whichever it is, you want to, the Scott Marine boiler, whichever it is which you want to use, it depends on some of those things we have talked about. So when you're choosing your boiler for whatever purpose, you must know the purpose, which you, like you have said, will determine whether it's fixed or not. Like if it's in industries, definitely it should be fixed. If it's in a locomotive, like in a train, then of course it's a mobile, so you have to worry about that. In terms of that, those are a few choices. You need to know the types, like we have said. We have what is the content of the tube, how many tubes, and what is the orientation of the axis of the shell, and so forth and so forth. Those are important things which you need to know. So let's stop at this particular point. We'll pick up with other lectures.